Distance education. This is MBF3C, grade 11, college prep math. I'm Pete, and I'm your teacher. So, welcome to the class today. So, we're in Unit 3. We just got started Unit 3 yesterday. I'm going to take a little bit of a step back. We spent a bit of time talking about the sign of and about right triangles in general and the sine ratio in particular, and that'll pay off in this lesson because we're going to do two more, and really we can just refer back to what we talked about yesterday. So it's really I think it'll be worthwhile here if we just go back and take a look at some of this introductory material that I showed you. Now, it's not in the text. They're kind of making an assumption that you're an expert in right triangles, which, if you've been out of school for a little while, that stuff might not necessarily be on speed dial. So when we're talking about right triangles, what we're talking about is triangles that have a 90-degree angle for one of the angles. Okay, now just it can only have one right angle. Okay, 90-degree angle, also known as a right angle. It can only have one of them, and if you doubt that, then I encourage you to try and draw a triangle that has two right angles. And if you do that, I'd like to see that. Okay, it's just you'll sort of see one of the angles is 90 degrees, and then the other two, the sum of the other two angles have to be 90 degrees, because the rule is that all the angles in the triangle add up to 180 degrees. So that if one of them is 90, we know that it's a right triangle, and the other two have to sum to 90 degrees. So neither of the other two angles can be 90 degrees, right? If one of them is 1 degree, then the other one has to be 89 degrees. If one of them is 45, the other one has to be 45. It's kind of nice when we're working with right triangles because of that, because we have that 190-degree angle, and then we can make a few assumptions, and it kind of simplifies the situation for us a little bit. Okay, so a right triangle or a right angle triangle is just a triangle that has a 90-degree angle for one of the angles, and a properly drawn right triangle will include this little box at the right angle. And what that little box is your seal, your stamp, or whoever drew it, saying, I guarantee you that this is a right triangle. That's what they're saying. And it means that you can make all the assumptions and you can apply all the trig identities that we're studying in this lesson. Okay, if that isn't there, you're really on shaky ground if you're going to try and apply those trig identities, even if it looks like a right angle, because it could be 89 degrees. It could be 91 degrees, and then you can't apply all these trig identities. You have to wait until we get to chapters 12 and 13. No, 12 and 13. Lessons 12 and 13 to learn what we do if it doesn't have a right angle in it. Okay, so this only applies to right triangles. Now, I've drawn them with the right triangle down to the left. They can be drawn in any orientation. It's pretty conventional to either put it on the left or the right. So basically on the base of the triangle, the right angle will be going up either on the right or the left. But you'll see in the text that they draw them upside down every once in a while just to kind of try and throw you off. Okay, what else to tell you about right triangles? So there's different names of the right triangle. If we look at this diagram here on the right-hand side, the longest side of the triangle is the one that's opposite the right angle. Okay, so it doesn't touch the right angle. If you see this blue, which I'm now tracing over in red, it doesn't connect at all to the right angle. And so the side opposite the right angle is always called the hypotenuse. Okay, we abbreviate it H or HYP sometimes if there's another H, if we're using H for some other purpose. You don't have to write out a hypotenuse every single time, but that's what it's called. It's always going to be the longest side of the triangle. And it's just another rule. Now, the other two sides are just in general called legs, right? So somebody will say, here's a triangle with the hypotenuse 10 centimeters and legs 4 centimeters and 2 centimeters. Okay, so now you know what they're talking about. The hypotenuse is the longest side, and then the other two legs, and it doesn't matter, which is which if they're just talking about a general triangle, right? The other one they'll say something like, um, yeah, well, anyway, that's when they refer to the legs. So a hypotenuse and then the two legs. Okay. Now, going back over to the left-hand side, it's a convention which is actually kind of broken even by the text. Um, the convention is to identify the angles with capital letters of the alphabet, usually consecutive letters. So in this case, we have a triangle, and I would call this triangle, I'd call this right triangle A, B, C, right? And that's it. So angle A, right, is an angle. Angle B is 90 degrees because it has a 90-degree symbol on it, and then angle C. And we know that A plus C add up to 90 degrees as well. Now, one of the conventions that we use is that the side opposite an angle, say, for example, capital B over here, is designated with the smaller case letter, so little b. Okay, that's how it's usually designated if we have a diagram or something like that. Now, there is another way that it's designated, and your text does this sometimes, and it's just it's just editing, basically. Somebody didn't edit it to be consistent, which is actually, in a way, it's good because we want you to see that there's two different ways to do it. There's sometimes the sides are designated with the two angles that are at each end of it, so we'd call it side AC. Okay, and it's just, again, it's another convention to put them in alphabetical order. So, but you could call it CA as well. I'm certainly not going to take any marks off for reversing the orders of the letters, or whether you use little b or whether you use the capitals. That method, it doesn't really matter to me anyway, because they're all valid. So big C, angle big C, and then the side opposite angle big C is side little c. Okay, or you can call it side AB if you want. Okay, because there's A, there's B. Now notice the side opposite little big C doesn't touch big C at all. And that's how you know that a side is opposite. It doesn't touch it, right? The other side, the side A here, you can see that it touches side C on one end, and the hypotenuse also touches angle C. Sorry, did I say side C? Angle C. Okay. So that's pretty much a review of triangles. Okay, so now let's get to the lesson material. So this is lesson 11, unit 3. So you're going to need that unit 3 handout. This is page 2 of that unit. I think that the first page is the cover. So what we did yesterday was we went through this idea that if we know, well, if we know some things about the triangle, the right triangle, then we can actually work out the rest of the information about it. So if we have an angle and maybe a side, then we can actually work out other angles and sides in the triangle. And it just happens to work out really nicely for right triangles. In fact, we can, with a fairly small amount of information, we can actually work out any triangle, but we're starting with right triangles because they're the easiest of all. Right, and that part of it is because we already have a piece of information by the fact that it's a right triangle. We know that that angle is 90 degrees. Now, there's an important concept here when we're talking about these trig ratios. Okay, so we're talking about the sine ratio, which is on your calculator. There's a button to calculate stuff to do with sines. It's called SIN. That's just an abbreviation for sine. But it's pronounced sine, even though it's written S-I-N-E, or sin. You can call it that. You can write it S-I-N if you want. Now, the sine ratio is the opposite over the hypotenuse, right? It's the length of the opposite side over the hypotenuse. Now, here's the important concept. As far as angle A is concerned, the hypotenuse is always the longest side of the triangle. It's always the one opposite the right angle. That's always the case. Doesn't matter whether we're looking at angle A or even angle B up on the other side. However, the side that's opposite angle A, let me put it in black here. This is the side that's opposite angle A. You notice it doesn't touch angle A. Okay, so as far as angle A is concerned, this is the hypotenuse right here, which touches it. It's opposite the right angle. And the opposite side is on the other side of the triangle, and it doesn't touch angle A. But if we were to reverse things and say we want to look at angle B here, notice that for angle B, the hypotenuse is still there. It's because it's always going to be the same. But notice that the opposite side now is this one right here that I'm marking in green. It's a different opposite side. Okay, so be really careful with that when you're working out angles. When you're working with angles, when you're working out on the sine ratio and all the other ratios, the hypotenuse is always in the same place, but the opposite side changes depending on which angle you're looking at. Okay, and that's really the key here. Now, the way to remember the sine ratio, sine is opposite over hypotenuse, is this little memory aid, which I have up here. Mnemonic is what it's called, and it's SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. And if you can remember that, you're going to know all of your three trig identities, because S is for sine, which is the opposite over hypotenuse. That's the part of it. Okay, now how do you remember what SOHCAHTOA is? Well, to me, SOHCAHTOA means I heart triangles. Okay, that's what it means to me. I love triangles, SOHCAHTOA. Okay, in whatever language you want it to be in. Okay, SOHCAHTOA. A lot of high school students, when they're taking a math test, the upper right-hand corner, you'd think that their name was SOHCAHTOA, because right where the name usually goes, they write SOHCAHTOA. That's the first thing they do. Okay. So now, the way this works is that the sine ratio, the length of the opposite side divided by the length of the hypotenuse, that is just a ratio. Okay, it's just a number. But the thing is that you could make a table which relates that ratio to the angle A. Okay, you can actually make a table, and the sign button in your calculator has such a table. Okay, there's also some fairly complicated formulas that will work that out for you too. It's not the sort of thing that even the most hardcore mathematician wants to take on. I mean, it's doable, but I think most of us would just press that sign button. Okay, so here's how it works here. Let's say that we want to find the value of x. This is example one. I'm going to speed up a little bit after this, but so we want to find the value of x. Now x is over here. That's the hypotenuse. HYP. That's the hypotenuse. Now in your text it just says 12 for the side length. I don't like that because trigonometry, geometry is all about measuring things. Very, very few of the units we work with, or the numbers we work with, don't have units. So I always want to give it a measurement. So if it doesn't have one, I'm just going to make one. So we're going to call it 12 meters. So remember that the sine ratio, the sine of A is the opposite over the hypotenuse. It's the length of the opposite side over the hypotenuse. Now as far as angle A is concerned, that's the opposite right there because it doesn't touch A, and the hypotenuse is always going to be in the same spot. So it's opposite over hypotenuse, which means it's 12 meters divided by x. We want to find out x. Well, now we have two knowns, and in a equation that only has one unknown, right? We have two things that we know, one that we don't know. Pretty straightforward to find it. Now they go through this big, long, meandering thing here. I did it this way yesterday. What I said was that we had, we had the sine of, I guess I better fix up my little, okay, well, we can do this. This is fine. Okay, so I said that the sine of 43 degrees, which is the sine of A, is equal to 12 over x. That's what I said. And now what we're going to do is we're going to swap. We're just going to, and the effect of this, we're just going to swap x and sine 43. Okay, see right here, x and sine 43. And what that really means is that we're multiplying both sides by x, then we're dividing both sides by sine 43. So you're welcome to do that in these steps here, but what you end up with is just swapping x and sine 43. Okay, if you know, convince yourself that that works, and that works when you're multiplying things together. This is if this was a bunch of multiplications, it works. It doesn't work if you have additions though, or subtraction. Only if you're multiplying everything together can you do that. Okay. All right. So anyway, so we got x now on by itself. 12 divided by the sine of 43, and so all you do is in your calculator you hit 12 times, or sorry, 12 divided by, and then you hit 43. Hit the sign button, hit equals, boom, you have the answer. Now, it might go off the rails if your calculator is not set to measure things in degrees. Notice that 43 is a measurement. It's an angle, and it's measured in degrees. In high school, we use degrees. In college, depending on how far along you get, what kind of math you're doing, you might be using degrees. You might be using radians, which is abbreviated RAD. You might be using gradients, and that's particularly if you're getting into architecture, into maps, things like that. You know, it's one of those things. Let's put it this way: in all of my schooling, I've degrees in radians was all I really, you know, we learned a little bit about gradients, and I did a few calculations, and then was glad that I didn't have to worry about it. Anyway, so degrees, so if your calculator is not in degrees mode, you're not going to get the right answer. So I actually gave a couple of examples here. So the sine of 43 degrees, you should have 0.681998, and then a few more digits. The sine of 45, 0.707, 107, and then a few more digits. The sine of 60. Well, you get the idea, right? So if you're not in degrees mode, you're not going to get those numbers. You get something else. So there's usually a DRG button on your calculator somewhere. DRG, degrees, radians, and gradients. And somewhere in your display there might be a D and R, a G, or it might say DEG, right? It might say RAD, and then when you press the grad button, it puts a G in front of it. It's hard to know. But just if you're not getting, if you type 43 and then hit the sign button and you're not getting that number, try finding the DRG button and then press that button. All right, and then try it again until you get it set to degrees. Now, if you're having some problems and you can't get your calculator into degree mode, don't suffer. Take a picture of it. You know, photocopy it or something. Send me the picture, and I'll do my level best to tell you what buttons to press. Okay, I know a little bit about calculators, so I might be able to help you. Now, usually when you're calculating the sign of a number like 43, usually you enter the 4, you enter the 3, and then you press the sign button. And you don't have to press the equals. That's the usual case. Some calculators, like if you're using a graphing calculator, it's different. Then you actually have to type sine 43 and then press equals. Okay, so again, if you're having problems getting these degrees, getting these sine, this is the time to sort that out, because you're going to need it. You're going to have these skills, calculator skills on speed dial for the rest of this unit. Okay. Okay, so if you work this out, this example, and you're going to get 17.6 meters. You know, they worked it out. They weren't using units. Remember that everything you do in trigonometry is going to have a measurement except the actual sine ratio itself. That's the only thing that doesn't actually have units, because it's just a ratio. Okay, so let's kind of speed things up a little bit here. So you know, we were trying to identify the opposite and hypotenuse. Try these questions, because you really need to know this, or else it's just going to be everything's going to go horribly wrong in the next little couple of lessons. You have to be able to identify the opposite of angle E in this case, right? So the opposite angle E is the side that doesn't touch, right? And then the hypotenuse, they've drawn the triangle upside down, but you can see the square there. So the hypotenuse is opposite the square. Okay, there's your hypotenuse, H, Y, P. Now the book sometimes uses H, so that's why you can call it HYP if you want to make sure it's not confused for a variable. So in this case, the sine, this is the one case where there are no units when you're calculating the sine of something, and that is because you're dividing two numbers that have units, and so that those units actually cancel out, and you just end up with just a straight up number, a ratio. Okay. But the actual angle B, if you were to turn it into an angle, then you would you'd be able to. That does have units. It'll be degrees. Okay. Now in this case, you should try these. I put them on the board here. You should really try these. Make sure that you're getting those answers, because that means that your calculator is set correctly. Okay. And if you lend someone your calculator, there's a good chance it'll come back not in degrees mode. So something to double check there. Now, for something like this, question 4, where you're going to calculate the value of x. So x is over here. So we see that we have the hypotenuse at 3.7, right? And we have this 37 degrees. Now, if we needed the other angle, then we could we know that it's 90 minus 37 is what this other angle is. So, but in this case, the sine ratio, the sine of 37 is the opposite, which is x, divided by the hypotenuse, which is 3.7 centimeters. I actually did it down here, right? So there's x divided by 3.7 centimeters. Now, again, to get the x by itself, I just took this. I basically did what amounts to multiplying both sides by 3.7, right? Right. So if I divide this, if I multiply this by 3.7 centimeters, and I multiply that by 3.7 centimeters, okay? On this side, they cancel out, and we're left with x by itself, and that's what the second line looks like. Okay. If I seem like I'm going through this really fast, what you should do is probably look at the tape from yesterday or the video on the WASA archive or on YouTube. I haven't put it up yet, but I'll put it up. And then you'll be able to follow along yesterday, where I'm going maybe a little slower. Okay. So we have 3.7 times sine of 37, and then you just work that out on the left side, and boom, 2.2 centimeters. That's your length of x. Do not forget to put your units in, because if you put down 2.2, yeah, it's an answer, but you really have to have your units in there. I will take a half a mark off if you don't put your units in there, just to remind you that you need to put those units in. Okay. Once you get to college, if you're going, say, into veterinary assistant or something like that, you better believe that they're going to want you to know the difference between a liter and a milliliter if you're giving medicines to animal patients, right? So and if you're doing some automotive stuff, you want to know whether you're dealing in millimeters or in eighths of an inch or sixteenths of an inch, right? Okay, so make sure you get your units in there. Now, you can just sort of follow my thinking on this other side here, just at your own leisure. We ended up with no actual units here. CM, so I'd lose a half a mark right there. Oops, okay, I just stepped on some. The heater's only been here about 8 months now. Okay, so and then there were a couple more, so you can always do some more of these questions. Just do as many as it'll take until you're comfortable. Now, the last thing we looked at yesterday was the idea of once we find a ratio, how do we get the angle? Okay, so this is an example. We want to find angle A. This is example 2 on the top of page 5. Okay, in the middle of page 5. So they ask us to find angle A. All right, let's get things sorted out. This is the hypotenuse. Notice I put the units in. And this is angle A, which means this is the opposite as far as angle A goes, which means we can use the sine ratio. Okay, if we didn't have that, then we would have to do something else. But notice now we're not given an angle, we're just given two sides, which means that when we set this up, we're trying to find angle A, right? So the sine of A, or the sine of angle A, if you really wanted to do it that way, most of us would just write A, sine of A. It's 18 meters divided by 23. It's 18, which is the opposite, right? This is the opposite over hypotenuse. That's the sine ratio. The meters cancel out, and we just end up with this number. The sine of A is this number, which is a ratio. Now, if you went to school, maybe 15 years ago, maybe 20 years ago, or more than that, like I did, at this point, you'd look up in the back of your math book what the angle for this sine ratio is, right? And you'd write that down. Now, math textbooks have gotten a lot smaller because we don't do that anymore. We just use our calculators. Okay. Now, the way you do this is you find angle A, and it's the inverse sine. This is sine to the -1, exponent -1, and we call it inverse sine. I wrote it up here. Okay. And so it's written sine to the -1. And what this means is that function says, what angle gives me this sine ratio? And when you ask your calculator to do that for you, it'll give you the angle. Now, on your calculator, usually it's on the sine button. If you look above the sine button, usually it'll say sine to the -1 in some color, maybe yellow, maybe white. And what you're going to do is you're going to put this number in the display, which is the result of dividing 18 by 23. You'll look above the sine button at what color the inverse sine function is. Press the button of that color. If it's yellow, you press the yellow button. If it's white, you press the white button. In my case, it's blue, so I press the blue button. Then you press the sine button, and that gives you the inverse sine function. And then that should immediately give you the answer. If it doesn't, you try pressing equals, and you should have this answer right here. And now, because we started with no decimal places, if we just leave this as our final answer, 51.5, even though it's pretty accurate, it's a bit of false advertising. Because what you're telling people is that the 51.5 is accurate to one decimal place, right? Well, if you look at the original diagram, the two numbers that were given are 18 and 23. Those are not accurate to one decimal place. They're accurate to 1 unit, like to 1 meter, not half a meter. So, or 100 centimeters or whatever. So we round it to the nearest whole unit in this case. Okay, so I'm not gonna. I'll say something if you're giving me more precision than what really is warranted. I'll put a little note there. I'm not going to take marks off though. But it is important to understand that you can only show as many decimal places in your final answer as the least accurate number you used in your calculation. Because otherwise you're basically telling whoever's reading it that you put 6 digits of precision on there, that wow, this is a very accurate number. It's accurate to 6 decimal places. But in fact, it's not, right? Your calculator gives you those digits, but you can only really state 1 decimal place or maybe even none and round to the nearest whole number. Okay. So there you go. So that was example 2. And then there's some practice finding inverse sines, so you can actually work those out then and look at the answers in the back. Okay. Now, when they give you a fraction like that, what they're saying is that this is a ratio. This is the opposite over the hypotenuse. So you could actually draw this triangle that they're giving you, because this is the hypotenuse, and we know it's got to be 7. And if this is angle A, then this has to be 3 units, right? Because that's going to be the opposite. So you could actually see, you can draw the whole triangle just based on that. Okay. And then now for 6, they've already divided out the answer. So basically, you're going to just going to find the inverse sine of that. It's the same as question question 5. Okay, just they've given it to you in a way that you would normally have it in your notes. Formally speaking, you would then, I'll just go over to this one because there's room. Formally speaking, we would say angle E equals sine to the -1 7 over 11. That would be our next line, and then we would say angle E equals, and then whatever that answer is, that's the way we do it. But typically in our calculation, we typically just skip right to there. It's the same as if you have, you know, like if you had x squared equals 25. Technically speaking, you should really write that, right? But most of us would just skip right to there. Okay, as long as it's clear, you can do that. If it was a really, if it was a lengthy calculation, you'd probably want to show every step. Okay, so and that's about it. So for question 7, then you're just practicing finding that angle. Okay, you're finding the angle. Now, hopefully they don't try to trick you. Yeah, no, it should be fine. If you didn't have an opposite, if they just gave you an adjacent, it would be kind of, yeah, no, this is good because that's the hypotenuse. If they just gave you an adjacent, then you'd end up having to find the other angle and then calculating it that way, subtracting it from 90. Okay, and I think we're good. All right, well, now that we've learned all about the sine ratio, take everything you learn about the sine ratio and apply it to the cosine ratio. If you remember the SOHCAHTOA, we've already learned about the sine ratio, the cos ratio, the cosine of an angle, of say an angle A, is equal to the adjacent over the hypotenuse. So it's the same hypotenuse, it's just we're not picking the opposite side anymore. We're picking the adjacent side. You see that? So this is the hypotenuse right here. There. Okay, yeah, okay, just pretend I really do know how to spell hypotenuse. It's written right here. This is the hypotenuse. There you go. Hypotenuse. And this is the adjacent, which we do A or ADJ. ADJ. Wow, I'm having my problems today. Ah, okay. ADJ. There you go. Okay, so instead of the opposite, and remember again that the adjacent opposite will switch around depending on what angle you're looking at. So the adjacent, and it's easy to tell the adjacent because it's not the hypotenuse. The hypotenuse is always the same, but the adjacent side is always the side that touches the angle you're looking at that's not the hypotenuse, right? So for the cosine ratio, the angle is actually in between the two numbers you're using, the hypotenuse and the adjacent, right? So the cosine ratio is adjacent over hypotenuse. That's the ka in SOHCAHTOA. Okay, and everything I told you about the cos ratio is the same as the sine ratio. You can find a missing side with it. You can find a missing angle with it, and yeah, that's pretty much it. So let's take a look at this. Okay, now one of the things that's going to happen as you get further into the unit, especially in the key questions in the last batch of support questions, is they're not going to tell you which one to use, right? So you'll just have to look at what you have, what they give you in the diagram, and then work out which of the trig ratios you need. There's 3 of them, right? So it can be, right, they'll give you one of 3 scenarios, and then it's up to you to pick the right tool. So in this case, they want to know x, okay, and we have a, and we know that the cosine of a is equal to the adjacent over the hypotenuse. So in this case, the cosine of 43 degrees, 43 degrees equals adjacent, which is, now, we got to watch it here because that's the hypotenuse. And so then that's going to be the adjacent, right? The adjacent is the one that touches the angle that we're looking at. Okay, not the opposite. The opposite would be the sine ratio. If they gave us this one right here, that's the opposite as far as angle A is concerned. Okay, if they gave us that one, no problem. We actually can deal with that because we know sine, we know cos, right? The only problem we have right now is if they gave us the opposite and the adjacent, they didn't give us a hypotenuse, and we kind of wondering what to do for about another 5 minutes. Okay, so to coast 43, A is the adjacent, so that's 15, let's call it meters, um, over X meters. There you go. Now, the only issue here might be to get that X all by itself, but remember the little trick, right? The little trick that I showed you. I'm going to show you the little, I'm going to show you the next line and then I'll show you the little trick. So the next line is X equals 15 meters over the cosine of 43 degrees. Okay, that's the little trick right there. No, that's the result of the little trick. Um, so why was I able to do that? Well, if we do a little aside here, I meant to do that in green. If I have this one right here, and I have cos 43 degrees equals 15 meters over x, and I want to get x by itself, then what I can do is I can multiply both sides by x. I'm allowed to do that. Okay, and then when I do that, these x's cancel each other out. Okay, so I'm left with x cos, cos 43 degrees equals 15 meters. Now I want to get rid of cos 43 degrees, so I'm going to do cos 43 degrees. I'm going to divide both sides by the cos of 43 degrees. You see? And then it's going to cancel that out on that side. And so when I rewrite this, I end up with x equals 15 meters over the cos of 43 degrees. Now, if you want to show that in your calculations, then please do. You know, if you want to show it as a little aside, you can do it that way. I just got to make this degree symbol look a little better. Sorry about that. It's a pretty nasty looking degree symbol. All right, we can do this. There we go. Okay. Wow. All right, I'll try it again. Okay. Okay, that's better. I think the down near the bottom of the just smart board, it's just a little harder to line my pen up here. Okay. So yeah, if you want to you can go from this step to this step. A lot of mathematicians do, but you can certainly put in the missing steps, those extra little steps that kind of show the intermediate, right? What the effect of it is, of doing that little trick, is that those two swap, right? You multiply by one, you divide by the other, they swap places. Okay, and the beauty of it is you end up with x by itself, and all of these things are calculated, right? 15 divided by cos 43, boom, hit the button, and you should end up with what they show here, 20.5 meters. Don't forget the units. Okay, but let's try it. Actually, just want to make sure that everything's cool here. So it's a 15 divided by, and then I do cos 43, but most calculators do 43 cos, and I end up with 20.5099192, which is way too many decimal places. It really should be 21 meters. I think if we look at the, yeah, everything's to the nearest whole unit, so we really want to, you know, and you'll notice that they give it with one decimal place, which is kind of wrong. I give it with a whole number, and the difference, the 21 or the 20.5, it's not that much of a difference. And when I'm marking something like that, I'm looking for your solution. So, you know, if it was 21, if it was 20.5, you'd get the mark. Okay, if it's 20.5, I might point out that you're showing too many digits of precision. Now, this wavy equal sign, it's just two wavy equal signs. It's not actually on the standard keyboard, but a single one is in the upper left-hand corner, right above the tab key, just under the escape key. It's called a tilde, or twiddle sometimes. But anyway, and so you're making just two of them. You're just stacking two of them up. You can't do that on your standard keyboard, but when you're writing, it's a two and crooked equal sign. Now, if you're interested in learning how to type any of these, just let me know. I have lists of codes. You use alt codes, so it is possible to type them on your keyboard. It's just you have to kind of have a table of codes, or you have to memorize some of them. Okay. All right. Let's see here. So that was the cosine ratio, and really we're just going through, you know, you don't want to name the side, you want the adjacent to angle E. There's E, so that's a hypotenuse. So what's the one that's adjacent to E? That's this one right here, right? So you can call it GE, I guess is what they're looking for, that sort of thing. Okay, so you can go through all of these. I'm just gonna, assume that you can do those, very similar to the sine. I want to get on to this next one, and it comes with a little bit of a warning here. Actually, check these diagrams carefully. I think they're okay, but at least one of them is wrong. I think it's this one. Yeah, this one right here. This is the tangent ratio. This is on page 12, and this diagram's wrong. So the tangent is opposite. Tangent is opposite over adjacent, right? So, um, so the tangent ratio doesn't use the hypotenuse at all. Okay, so it's opposite over adjacent, and again, um, it's relative to the angle you're looking at. If you had an angle B over here, you would actually have what was the adjacent for A is now the opposite for B, right? So it is kind of cool if you have two angles, the tangent for the two angles is just the opposite. It's the inverse, reciprocal, sorry, of the fraction, if you have the fraction. So anyway, so the tangent ratios for those cases where you don't have a hypotenuse, you just have the length of two sides. And that's a pretty common thing. Actually, I tell you what, I was using this very ratio just the other day. I was setting up a tripod. Okay, I was setting up my camera tripod, which is like this, and I knew I wanted to know how long to make these legs, right? How long to make the leg of the tripod, and I wanted to have that sort of in my mind so that when I go out in the field, I could just deploy it very quickly, right? And what I knew was how high I needed it to be. So I knew this height right here, okay? And I also knew this angle here because that's one of the specifications. It was around 22 degrees, 22 degrees, okay? Right? And so I needed to basically figure out this length here, right? Okay, so I could have, if I'd have known this distance right here, I could have used the tangent ratio. In the end, I ended up using a different ratio just because I didn't always, that distance really depends on the length of the leg, so I didn't want to depend on that one. But anyway, just one of those things where, you can use trigonometry every once in a while, and just to sort of help simplify things. I could have just kept extending that leg until I found the right height, which I think is what a lot of people do. But if you can sit down and calculate it for 1 minute, it's probably faster than any kind of measurement. Okay. So the tangent ratio then is the one that doesn't involve the hypotenuse, right? So if we think of SOHCAHTOA, all right, notice that you got the hypotenuse, and then the TOA, opposite over adjacent. Okay. So that's the one that you're gonna use when you don't have a hypotenuse. All right, well, let's take a look at what we can do with this. So we're going to go through the tangent ratio, adjacent over hypotenuse, and it's the same as the other ones. In each triangle, name the side adjacent to angle F. There's an angle F. Now remember, this is a hypotenuse, and that doesn't change. So then this is your side that's opposite, and what is that? It must be FG. Okay. And opposite angle Y, there's angle Y. Remember, that's the hypotenuse. So now they've asked for opposite. Watch that, eh? So that should be XZ or ZX if you really want to. I'm going to put them in alphabetical order. Okay. So here they want you to calculate some tangents, and this is the one that's just going to be a straight up ratio. So you can give that one a try. And there we go. Now let's get into there should be another batch of support questions here. Oh, okay, well, we're right into key questions. Lovely. See, the thing is that when we're being asked to answer some questions in the key questions, because we've had sine, cos, and tan, unless it tells you which one to use, you have to pick which one to use. Okay, so in this case, they want the sine. That's great. In this case here, they want the value of x, right? So this is key question 4. Okay, well, what do we have here? Okay, we have an angle, right? And that's the hypotenuse. Hypotenuse. So what is this this side relative to I here? So that's the opposite, right? So which one is opposite? Okay, we have a hypotenuse and an opposite, so that's the sine, right? So the sine of 53 degrees equals x over 3.7 centimeters. And now you're on your way, right? You could pretty well hand your calculator to your little sister, and then she could work that one out for you, your little brother, right? That was the hard part, was coming up with that equation. Okay, you're going to get marks for that part. Okay, so if you ever are looking through your key questions, your assignment, and you see that you've got an X at the end where the answer was wrong, but you still get marks for it, it's because of that. It's because you set it up correctly. And so, just maybe type in, pressing 2 buttons at the same time with your thumb on your calculator. That happens quite a bit. And that's not such a serious deal. The more you work with numbers, the more you'll recognize when you get a wrong answer. You'll be a little more aware. So the important thing is being able to set it up. Well, let's take a look at B here. We got E. We have our X. Now that's the hypotenuse. So we know for sure it's going to be either sine or cos, right? Because we have a hypotenuse. So what is it? This is the opposite. Sine. It's sine. Yeah, that's what it looks like anyway. Is that correct? Yeah. So it's just 2 sine questions. Oh, well, not so interesting, but okay. We're doing a bunch of inverse. So inverse sine, inverse cos, inverse tan. Oops. Okay. Let me just get it down when you see it's inverse tan. Now a lot of people would put them in brackets. Okay. It's up to you. Okay, I'd put them in brackets usually. Okay. And now, see here, they want you to calculate E. So you have to decide which one, right? First, I'd go by. Now, notice that I educate my diagrams. I strongly recommend you do that. Write down whatever you know about the diagram on it, any measurements, right? It's just a good habit to get into. And even if you make a mistake, having information on your diagram will help you diagnose that mistake, right? If you've realized that you got your hypotenuse wrong, it's pretty easy to actually go back, even though you've done the whole problem, and fix that, right? Change the hypotenuse number. Okay, so there you go. So you'll try those, and just looking at this, it looks like they're all sine or cos, and it's kind of unfortunate. Okay, now the word problems. Let's look at some of these word problems. It's sort of, a lot of times a diagram will really help you. They've shown a diagram here, which is good. If there is no diagram, I strongly recommend you show a diagram. I'll give you a mark if you get the diagram at least. If even if something goes horribly wrong, if you get a diagram that shows what you think the situation is, that's worth a mark. Okay. All right. So a guy wire, this is the wire. That's the thing that holds a power pole, right? You see them sometimes. When the power poles are in swampland, they'll put those wires just to hold them up. And for the tall radio towers, the really tall antennas, you'll see the wires holding them up. Those are called guy wires. I don't really know why, but anyway, they're called guy wires. And so this is a fairly small one. It's 13.5 meters long, supports a vertical power pole. So this is the diagram is actually a very good representation of it. Now do watch it. I've seen a few of these where somebody's changed the numbers in the question and didn't change the diagram. So always go by what they give you in the question here. And if it doesn't match, then change the diagram. All right. And then, of course, I'm not going to take marks off if you use the numbers from the diagram, but it makes it easier. Okay, so it says the wire's fastened to the ground 9.5 meters. So this wasn't given on the diagram. It's just the distance. Calculate the measure of the guy wire and the ground. So that's the angle we're looking for. You can call it A. You can call it anything you want. That's the angle we're looking for. So what can we use? Here's the beauty of this is that we have all three sides. So you know what? Sine, cos, tan, any one you use will find you that answer. It doesn't matter. You can pick one. That's kind of neat. Okay, now for question 9, this is the sort of thing that once you draw a diagram of it, it'll be a piece of cake here. Okay? A 5-meter ladder is leaning 3.7 meters up a wall. So there's your wall. Okay, that's the ground. I'm going to draw the ladder in red. There you go. There's a ladder. It's 5 meters long. That's our ladder. Okay, and it says in the question it's 3.7 meters up a wall. So that means this is 3.7 meters. That's that distance right up there, you see? Okay, now it doesn't say that the wall is at right angle with the ground, but that's a pretty safe assumption to make. Okay, what is the angle the ladder makes with the ground? Okay, there you go. So we can call that A or whatever you want. We can call it red A, there we go. Okay, that's the angle we want right there. So what do we have? We have a hypotenuse, we have an opposite. Yeah, you can figure out which one to do. But this diagram here, that diagram, at least worth a mark. A question like this probably worth 3 marks, right? So mark for your diagram, a mark for setting it up. So you're going to pick the right ratio, plug the right numbers in, and then another mark for actually getting the final answer plus your units. Okay, so that's how you get your marks for that. Okay, and it looks like somebody's giving you another ladder question. So that's pretty cool. So once you've done 9, you'll be all set. Now, one last little thing before we get done today is question 10. A kite has a string 100 meters long, so there's your string, okay? And it's anchored to the ground. Of course, they're always anchored to the ground, right? So the kid doesn't go flying off there, okay? And it makes an angle with the ground at 68 degrees. What is the horizontal distance of the kite from the anchor? Watch these questions. Sometimes you want to know how high the kite is. Sometimes, like in this case, they want to know what the horizontal distance. That's this distance right here. We call that little h, right? If you want. But then, don't get confused with the hypotenuse. We could call that x, right? So we don't have a whole lot of information. We have 2 pieces of information. We have an angle and a hypotenuse. Can we find out what that is? Absolutely. Okay, absolutely. So again, there's something question where the diagram will really help you. Okay, now look, here's question 12. Don't skip over this question. It's probably worth 2 marks. Don't skip over it. SOHCAHTOA. SOHCAHTOA helps you. It's a memory aid. Helps you do the trig ratios. SOH is sine is opposite over hypotenuse. CAH cos adjacent over hypotenuse. TOA tangent opposite over adjacent. Okay, and give an example, okay, of how you would use it. Just pick one of the questions from the support questions. Probably make it easier for yourself. All right. Well, I guess we'll call it the end for now. So tomorrow then we'll come back and we will look at how to do this when we don't have right angles. We'll spend a couple of days working on that. All right, thanks for joining us. Talk to you more.